Hello, my name is Malte Meinshausen. I'm from the University of Melbourne, and today my presentation is a contribution to the IPCC side events to the COP27 in Sharm el-Sheikh. Now, the online talk didn't really work out, and we could only hope that these large gatherings in the future allow for much smoother online participation. We had fantastic IPCC approval sessions that were all working smoothly online. So we can only hope that in the future we can avoid a lot of air miles together if these technicalities are sorted out. I now walk you through the slides on estimating warming levels from emission pathways that really shows a strong collaboration between Working Group 1 on the physical climate science and Working Group 3 on mitigation aspects. And there are lots of people to be thanked for: Zebedee Nichols, Jared Lewis, Pierre Foster, and others who all worked on the climate emulators in Working Group 1 and were also involved with our colleagues in Working Group 3. Now, the talk is going to be about four things. First, the Working Group 1 projections for the future, the temperature projections in particular, and how they are encapsulated by the climate emulators. That allows us then to not only assess a handful of scenarios, as Working Group 1 does, but allows us to assess thousands of scenarios. Working Group 3 has 2,000 scenarios to start with, and then after a little bit of wetting, around 1,200 are assessed in terms of their global mean temperature outcomes. That allows us then, with emission profiles, etc., to make statements about 1.5 degree and lots of other things, so that temperature assessment is really crucial to make policy relevant results. And then I conclude with a few notes on the comparison between the IPCC special report on 1.5 degree warming from 2018 and this AR6 report temperature assessment, what the differences are. Now, if we look at historical warming, then this is the assessed observational best estimate of what global mean temperatures did from 1850 to around 2020. And you see here in gray period, the period which we often take as proxy for the pre-industrial from 1850 to 1900. And here the little gray lines show the CMAP6 models. So these are the big Earth system models, and you can run for a few scenarios, but not for 1,200. And here they're all spread around this observational record, which is in dark blue. In the recent period, 1995 to 2014, we can see here the dots indicate what the warming was across the different CMAP6 models compared to this 1850-1900 baseline. If we look at the observational record, that is a bit towards the lower end. This is 0.85 degrees. And that is well known and described in IPCC that there are a few hot models. So this is really the thing that we care about, the assessed observational record, 0.85 degree warming in the period 1995 to 2014. Let's have a look how the climate emulators that are calibrated to replicate this history fare. So here we have Cicero, simple climate model in pink, and that does a pretty good job. And we have also the FAIR model that does also a very good job. We have here the MAGIC model, also a pretty good job, and the Oscar model, also a pretty good job. So in the history, these climate models, after they are appropriately calibrated, they replicate historical observations rather well. That is what they're designed to do. This is kind of by design. Now let's have a look in the future. Here's the SSP 126 scenario. That is the second lowest scenario. And again, here, these little gray lines show all the global mean temperatures from the large CMAP6 models. That is the near-term period, 2021 to 2040. And here you see, again, the range of CMAP6 models. 2041 to 2060 is the midterm period. And then we have end of century also here. Now, working group 1, for the first time in IPCC history, took multiple lines of evidence and combined them. So there was also our knowledge about equilibrium climate sensitivity and transient climate response combined with the insights from the CMAP6 models, from a constrained set of CMAP6 models. And this is what is now shown here. This blue area with the uncertainty range is the global mean temperature assessed range for the SSP 126 model scenario. That is, again, the low scenario. And working group 1, particularly chapter 4 therein, did that across all the illustrative scenarios. Again, that handful, there's one lower one and there are a few higher ones. And we see here again in this dark blue range, this is the assessed temperature range where IPCC scientists say this is our best estimate for the median projections as well as the uncertainty range that we can come up with. Now, this is what we want to replicate with the climate emulators in order to apply these insights onto the working group 3 scenarios. Let's have a look how the climate emulators, after all the calibration, do. And they not only try to replicate this scenarios, but at the same time, also the very high scenarios, the very low scenarios, and a whole bunch of indicators. So for example, you see here, again, the Cicero model in pink, and it does very well in the near term. In the midterm, maybe a tad bit too low in the median over the long term, but the range is very good. Similar here for the FAIR model and for the MAGIC model. You can see here the range of all these 3 emulators is pretty well replicating what the working group 1 assessed range of temperature outcomes under this scenario is. And then we have also one more model that wasn't fully calibrated, so the range is not quite as high, so we don't use it for working group 3 assessment, but that is here to get the full picture. And if we compare them, so again here, these big fat blue bars are the assessed ranges, and then the pink, the Cicero model, turquoise, the FAIR model, orange, the MAGIC model, and Oscar here, in red. Now, FAIR and MAGIC also do something that normally is not done with the CMAP6 models, which is starting the runs from emissions. That includes then the carbon cycle uncertainties. There are also emission-driven runs with some CMAP6 models, but by standard, they are concentration-driven. So here, with FAIR and MAGIC, then you have these carbon cycle uncertainties included. When I go back and forth, and then here also in MAGIC, the carbon cycle uncertainties, once you include them, the projected temperature ranges get logically slightly wider because we add more uncertainties. Now we take MAGIC and FAIR forward in order to assess all the working group 3 emission scenarios. And thanks to that work that is more in detail described in cross chapter box 7.1 and chapter 7 of working group 1, we now have a powerful set of tools that allows us to use the insights from working group 1 for a whole bunch of other setups. And here you have very detailed indicators of how these different climate model emulators fare against warming, ocean heat content change, aerosol forcing, greenhouse gas forcing, methane forcing, airborne fraction of CO2, etc., etc. And the wide fields are normally the ones where the climate emulators fit quite well with the assessed ranges of the working group 1, and the blue and the orange areas are where there's a little bit of a difference. Now, let's go to then apply those to the working group 3 scenarios. And when we do this, we can then assess the global mean temperatures and then categorize the working group 3 scenarios along those temperatures. For example, here is the median across all the 97 medians of the 97 scenarios that are in this C1 class. The C1 class is defined as having only a no or low overshoot of 1.5 degrees. So they are around 1.5 degrees between 2040 and 2050. And then they are with a 50% likelihood or higher, again, below 1.5 degrees by the end of the century. Now, then here is also shown the medians on the side. When we go to the next higher class, the C2, that has a higher overshoot. But by 2100, we also have all these scenarios coming back to below 1.5. Importantly, we should not forget the uncertainties that I was just talking about. And these uncertainties are now shown here with the bars. So even if we aim for a scenario that has a best estimate warming below 1.5 degrees, we might well end up, if the climate system is a bit more angry than we think, at above 2 degrees. And that has ramifications, for example, for our adaptation, preparedness, planning, etc. Even if we aim for 1.5, we might end up above 2 degrees. And that is what you see here in these bars. Now that figure, that particular figure here from Working Group 3, the summary for policymakers is fairly rich. It shows also here in these dark bars the peak warming that is estimated. And here you can again see very clearly C1 has only a no or low overshoot, whereas C2 has a higher overshoot here indicated by this dark filled out box. If we go to the next class of scenarios, that is C3, they are above 1.5 degrees by 2100, but they stay below 2 degrees all the time with at least a likely chance. So these are these dark purple scenarios likely below 2 degrees. We then have also the C4 scenarios that are below 2 degrees with a 50% chance, and C5 and C6. And there was also one question on which scenarios start to or still continue to increase by 2100. And you can see from the category C5 on, there are quite a few scenarios that by 2100 still on a slight upward trajectory. Over the last weeks, we also saw a lot of warming estimates in the press about what happens if we just stay at currently implemented climate policies. Where do we end up by the end of the century? Of course, there's a long extrapolation of 70 years of emissions, but if we assume roughly similar effort, etc., then most of the estimates end up here in this 2 to 3 degree range. If we were to assume that the net zero pledges are all fulfilled, then we would end up slightly below that. Now, there's also higher scenarios, C7 or C8. These are reference scenarios, but our assessment now is that given the dramatically falling renewable costs, etc., we would actually have to take additional money in our hands in order to achieve these high emission levels. However, the warming levels that these scenarios represent, they are not completely outdated, because, as I said before, if the world turns out a bit more angry in their climate response to our emissions, then even with the lower emission scenarios, we might end up at some of these higher emission scenarios, best estimate temperatures. So here at 3 degrees or higher. So they still provide useful insights. Now, these are the scenario classes C1 to C8 used in Working Group 3, and K1 is already also going to explain that some of these scenario classes have subcategories, for example, the C1 or C3 group. And in Working Group 1, where we mostly run the big models, we only have these handful of illustrative scenarios. We normally focus on 5. And the lowest 3 are here, the SSP 119 scenario. The SSP 2.6 is the low scenario that is similar to the C3 category, and the SSP 245 is here in that range of the C6 scenarios. The SSP 119 is then coming below 1.5 degrees by the end of the century, but has the same feature as the other C1 scenarios, that is around 1.5 or a slight overshoot, hitting the 1.5 by around 2030. And there are also a few more of these so-called IMP scenarios that you can see also in the presentation from Detlef van Vuren. They have specific other features that are investigated to make policy relevant insights. Now, The full beauty of the figure is, again, here you can see it in working group 3 in the box in the summary for policymakers, the box 1, and it's there, figure 1. So this is the full richness and beauty of that figure. Now, these were all the temperatures. Let's look at the emissions from some of these scenarios. And the next graph is the working group 3, again, from the summary for policymakers, the figure 4, and it looks at a few of these emissions. Here, for example, historical emissions, and then a few scenarios that just assume trend from implemented policies. So the policies that are currently implemented, where do they carry us by 2050 and beyond? You see here the interquartile ranges and then the wide uncertainties also for later years. And by 2100, understandably, the scenarios differ quite a bit about where do currently implemented policies lead us, because there's quite a bit of uncertainty. But just in comparison here, there are a few scenarios that go to 2030 levels here that are very comparable to where currently around COP26, the NDCs, the targets that countries put forward in the Paris Agreement, of where they would take us. Roughly stable emissions towards 2030, maybe a slightly a notch down. As you all know, there's a huge gap of emissions towards, for example, the 1.5 degree scenario. So this is here the lowest class of scenarios, the C1 scenarios. And here that gap is sizable, roughly of the order of a bit more than 20 gigatons by 2030. And here is the set of 2 degree scenarios. So those scenarios stay likely below 2 degrees. And you can as well see here quite a sizable gap, a bit more than half of the gap towards 1.5 degree scenarios. Now, the big question is now, well, if we don't enhance the NDCs up to 2030, so the targets of the countries, then what are the options left for thereafter? Now, the ship to 1.5 degrees has then most likely left the harbor. If we stay with these high emissions, we almost exhaust the remaining carbon budget for 1.5 degree within this decade. Thus, only reductions within this decade will put us on the path where we can still then aim for 1.5 with a low overshoot. If we go to these 2030 levels, roughly constant, then we have 2 options, basically. This is very steep reductions thereafter and playing catch up, and then still being able to have either high overshoot or below 2 degree warming, or we don't do the steep reduction and then we just get more warming than 2 degrees by our best estimate. So this is the steep route. This is not the cost-efficient route. The cost-efficient route is to start reducing now. And this, again, is the figure in the full beauty. You can see that in working group 3, in the summary for policymakers, it's there, the figure SPM4. As conclusion from this graph, as many other studies also show in the recent weeks, there's a gap analysis, and whether it's now here from the IPCC or the UNFCCC synthesis reports or the UNEP gap report, they are all pretty similar. Steep reductions before 2030, so this decade, are necessary to avoid either even steeper reductions after 2030 in order to still have a chance for below 2 degrees, or warming in excess of 2 degrees. Now, just briefly on the difference between the special report on 1.5 that came out in 2018 and here these results, the classification is actually very, very similar. And there was a lot of work done by lots of people in the background. Again, I mentioned here Zebedee Nichols or Jared Lewis or Sebastian Milinski or Jarmo Kirkstar or K1, Detlef, etc., many others. So there was a lot of work done. It turns out that the classification and the climate assessment is actually very, very similar. but there's a slightly higher peak and slightly lower warming in the long term. Now, this is the SR 1.5 setup. If we just apply to this low scenario SSP 119 that I also discussed earlier, this is the lowest scenario in working group 1. If we apply there the SR 1.5 setup, we get this, again, slight overshoot of 1.5, but basically staying around that, getting there in 2030 and or a bit later, and then going to lower levels. If we assume the new setup, then we get to slightly higher warming levels, but we then have slightly lower cooling. The reason is that for aerosols, and in particular, for example, nitrate aerosols, we now assume stronger cooling in the long term, but we have an offsetting effect that we assume a higher historical warming. So here you see the shift upwards in the historical warming that leads us to then, again, similar peaking levels. And you can see more of that analysis in, for example, here Nichols et al. 2022 in the GIL paper that goes a little bit more into detail. When we look at not only the SSP 119 scenario, but all the low scenario of the class of 1.5 with low overshoot in the SR 1.5 report, then they're shown here. And this was back then the setup that was used with Magic 6. Now the classification setup is mainly driven with, it is driven with Magic the 7, the updated version. And you can see here, if we calculate the global mean temperatures for these old scenarios, again, then we come out with very, very similar results, but they have a higher historical warming and a little bit more cooling in the future. Now the conclusion is here, SR 1.5 results and AR6 results are very, very similar, very comparable. And with that, I thank you. There are a few more resources in the working group 3 that I would encourage you to look through. And for example, here, a lot of rich figures on, for example, the non-CO2 warming and how we assessed it and what are the differences, in the working group 1 carbon budget setup towards the scenario analysis in working group 3. How do the different modeling frameworks of the integrated assessment models differ in their assessment of what are the non-CO2 driving forces for different temperature levels? So that is rich material in working group 3. We have all the emission milestones of the scenarios in working group 3 here in the table SPM2. And then we have also other papers that provide even a bit more background. For example, here Jarmo Kikstra, he provides this background on that warming assessment pipeline, and also goes into the regions that I showcased you for SR 1.5 and AR6 in a bit more detail throughout all the scenario classes. We also show here the difference in working group 1 assessment of the carbon budget and then the cumulative emissions of working group 3 pathways. Again, they're very similar. There is the working group 3 assessment is a notch more stringent than working group 1, but overall for 1.5 degrees, we have around 500 gigatons CO2 left. That is the carbon budget in the working group 1 table. And also for these 1.5 degree pathways that have a small overshoot in working group 3, it's also around the 500 gigatons that we have left from 2020 onwards. We are emitting around 40 gigatons every year. So we are vastly burning through that remaining carbon budget for 1.5 degrees. And there's also a bit more detail here, which I would encourage you to look into if you're interested. Again, thank you so much. And I hope you enjoy the other IPCC events that we provide as input for COP27. Thank you very much. Bye-bye.